Hi and welcome again. Today we are talking about binary trees in the list representation, and we're going to implement how we insert elements and how we print them in a breadth first search manner. Alright, so a binary tree is basically a data structure for storing data, and it is very efficient in storing data. And is also very efficient for searching data. And there are a lot of derivatives of the binary tree, for example the ADL tree or the BST, the binary search tree, which make it even easier and more efficient to search data. But the basic one is the binary tree. Well, the binary tree is somehow an extension of a list, in that sense that we have two children instead of one what was in the list. Alright, so let's have a look at the definition. We can say the tree has a root node and every root node has two children. And that leaves us also with some kind of recursive definition, because every other node is a binary tree again. And there are no circles allowed, meaning in this picture here on the right we have at the top the 1 as a root node, then the children 2 and 3, and there are no circles allowed that there is, for example, an edge from 2 to 1. Alright, so with the definition and that we say we have a lot of trees there, we see our first tree is 1, 2 and 3, where the 1 is a root node and 2 and 3 are the children. The next one is definitely the 2, 4 and 5, where the 2 is again the root node and the 4 and the 5 are the children. And we have the same on the right side with the 3 as a root node and the 6 and the 7 as the children. Alright, and the list presentation is then similar, that we have our item at some point there as a root node with what's storing some data, and then we have some next pointers to the two children. Alright, so let's go ahead and implement it. Well, at first I create a new file. I call it binary tree as list, and there I create a class called also binary tree as list. Well, in that I want a helper class that represents the nodes for me. So I call this class node, and it has a child left that I say now is none, and it has a child right where I also say it is none, and it has a value. And then I want to implement an constructor where I simply give the value, and it sets the value of my node. That will shorten the code extremely, because when we insert something we have to do that multiple times. So here I say value, and there I say self.value equals value, so we set that. Alright, the next we need is a root node, so I say underscore underscore to make it private, root equals, and there I say for now none. So how do we insert our elements? Let's start first by creating the function insert, and there we say we give it self, and we give it our value. And we say, because we want to implement both versions, the iterative and the recursive approach to inserting values, so we say here insert iterative. Alright, so here we say insert an element into the tree. And we can also say value is the value of the node. Alright, so at first we have to check if our root node is set already. So if our root self.root equals none, then we say self.root is equal to our node class. We create an instance for that and we say value, and then we are done with it for now. Alright, otherwise we create, or we have to go to a leaf. Here I said we are currently still in our node class, so we have to go one further out. So now we are in the binary tree class. That should be fine. Here they say self is not defined because our constructor needs also the self property. Alright, let's comment this here and say node is root node. And then otherwise we have to go through our list of nodes and figure out which is the first free leaf where we can insert our value. So for that we have to create at first a queue. We need to do that for our traversal of the tree, and we give that our root node, so it is self.root initially. In the next step we say while the queue is not empty, queue is not empty, or let's do it differently, length queue is bigger than 0. Then we go in and now we have to check is our current leaf, so we start with the left leaf of the node, is it free. So for that we get our first node. We say node equals our queue, and it is the first element in the queue. So now we can check if node.left equals to none. So we defined it by being none up here in our root class there. So if it is not set, then we create a new node. Then we say node.left equals self.node, and we give that our value object, and then we are done here. Otherwise we check if our node.right is equal to none, and we basically do the same there. So we say node.right equals, and that is self.node value. Here we can say here left node is leaf, and we can say here right node is leaf. And here I want a space to have it all nice and clean. Otherwise we don't have a leaf now, so we have to go leaf at position current node, or at current node is sufficient. So we say else. So now we have to check these two nodes too. So we say queue dot append node dot left, or we do it in one line. So we say extend and make a list out of here, and say node dot right. And with that we are almost done. The only thing we need to have a look now is if we remove an element, if we take the first element of our queue here always, then we also, once we are finished with working on it, we have to remove it from our queue. So we have to say here queue equals our queue, and there we say everything from our element 1 on. So we basically remove our first element there. Alright, so now it would be nice if we could print and check if everything worked out. Oh, here we can also put a return in. We better should put a return in. Because otherwise we might run through multiple nodes and yeah, we added multiple times. So let's create the print function. And there I say def print, and now I say def first search because I want to make breadth first search. So basically we print the first layer of our tree, the root node, then we print the next layer of our root tree, and so on. And that gets just self. And here we say, if our root node is none, then we simply print none. And then we are done. Otherwise, now we have to go through the stages of our tree, go through the layers of our tree. So we say we need a queue again, and we initialize that with our root node. So we say self dot root is our first element in the tree, and then we go in and say while our queue is not empty, so we check again if our length of the queue is longer than longer than 0. Then we want to append our current working nodes to the queue and to the nodes with that we want to work on still. So we have to say here again if, or we pop our first element here, we say node equals queue 0, and then we say if node.left is not equal to none, then we want to append it to the queue. So we say queue dot append node dot left, and otherwise we say if node dot right is not equal to none, we want to append that too. So we say queue dot append, and there we also say node dot right. Alright, so now we have our working nodes in it, so we can say print our current value at the node, and that is node.value. And once we are done that, we have to remove this node again from our list. So we say queue equals queue, and there we say 1 to the end, so remove the first element again. And here I have a writing mistake. Alright, that looks good. So let's try that out. So we say if the name equals main to enter our main class or main function to start the program, and there we say our bin tree equals binary tree as list. So we instantiate our tree, and then we have a data array where I say we take 1, 2, 3, 4, 5, 6, 7 for now. Well, let's do it. Yeah, let's leave it with this for now. And then we say for every element in our data array, we add it to our tree. So we say bin tree dot insert iterative, and we put in our value, that is ln. And in the end, we just print the tree and say bin tree dot print bfs. Alright, so let's see and hope that it works. So if we run it, we still get an error here in line 48 that it says root doesn't exist, and that is because here we're missing an underscore. Let's try it again, and there we go, we printed it. So we also had to have it in our list. Alright, so now that we've done the iterative version, let us do the recursive version. So we go in and set def insert recursive, and we get again our self and our value. And then we say inserts value into the tree in recursive fashion. Alright, so at first we have to check again, is our root node none? So if self.root equals none, then we can return none. Otherwise, I want to call a helper method where we say def insert rec, and I make this one private too, self, and it gets the value, and it gets a list of to-do nodes because we want to do it in layer-wise manner. So we can say here inserts value into the tree in recursive and breadth first fashion. Alright, so we can go in here now and say if we need a list to do that we are working on, so we always take the first element. The node we are currently working on is to do 0. And there we say if our node.left is none, then we want to insert it here again. So we say we say node.left equals, and there we say self.node, and we can give it our value. And we do exactly the same again for our right side. So let me copy that here quick. We say here right. Oops, that is there. So we have to use the right here. So that happens if we write here left is leave, and here we can say right is leave. Alright, so good so far. If we've done that, we insert it and we are done basically. Otherwise, we have to insert the nodes or to append the nodes to our to-do list. So if our node left not equal to none, then we want to say to-do dot append, and there we say node left. And we can say if node.write is not equal to none, then we want to do dot append node.write. So now that are the nodes we are working the next on. So we can call here again our recursion, and that is self.__insert recursive, and there we say value and to do. And what we have to do first, because we are already done with our node we currently work on, we say to do dot or to do equals to do, and there we remove the first element again. Alright, so good so far. If we insert something, then we simply run out here and we never get in somewhere again, so our recursions just go to an end. So let's have a look if that works. Oh, did we call it up here? No, we actually didn't call it up here. So we have to say here else. Now we call our insertRec method with our value, and we put our root node in a list, so we say self.root. Alright, so let's try it out. Here we say insert recursive, and when we run it, we just get none. So if root equals none, then we insert our root node here already. So we don't need this. We actually have to say here self.root equals, and there we want self.node, and that gets our value, and we are done. So let's see, that should work now. And as you can see, it works completely fine. So, ladies and gentlemen, I hope you liked that video and it helped you. If so, give it a thumbs up and subscribe to my channel to always get informed whenever I upload new videos. And yeah, tell me in the comments down below what you think about this video, or maybe you have some hints, suggestions, what I can improve or what you'd like to see here. Alright, have a great day, bye.